My dear friends, welcome back to Bee Spice. In this session, we'll discuss about gap controller. Okay. So hope you had watched my previous session on controls like PID, cascade, feed forward, cascade and feed forward, ratio, split range, all those we covered. Okay. So if you are not watched, you can spare some time and yeah, watch because a lot of concepts are all interrelated actually to understand the concept. In fact, if you see the gap controller, this is an enhanced modified PID version. Okay. So that is why I want to inform you all if you are a first time viewer. Okay, friends. So let's move on now. See, gap controller. What actually gap controller does what? See, gap controller, it controls the digital output or analog output to field, okay, based upon a target set point and measured process variable from the field. Very simple, right? It controls DO, AO to field based upon target set point and measured process variable value from field, right? So the output from gap controller normally controls it on-off valve, motor, but may also control other discrete devices or modulating control valves. Okay. So if required, this function block may form the secondary controller in a cascade configuration. That is why I told you can watch the cascade. You will understand what is the secondary controller, what is the primary, all those. Okay. This is a bit of outline about the gap controller. Okay, there are two types of gap controller. What are all those? One is the gap action controller. Okay, the other is the differential gap controller. Okay, friends. Okay, so what is this gap action controller? Very simple. It provides standard PID control action when process variable rises above high limit or falls below low gap limit. Very simple. Okay. When a process variable is between the gap limits, within the limits, the controller works sharply, reduced gain, or in other words, it provides no output within the gap limit. You got it, friends? So this is the gap action controller. Provides PID control action when process variable rises above high limit and low gap limit. And when process variable is between the gap limit, the controller works with sharply reduced gain or provides no output within the gap limit. We will explain all these, what is the gap, everything with a typical example in the next slide. Okay, now differential gap controller. It provides a standard on-off action when the process variable rises above the high gap limit or falls below the gap limit. You got it, friends? Yes. Gap action, PID. Differential gap, on-off action. Very simple. Okay. Then, when process variable is between the gap limit, the controller output remains at lost value. Here, the gap action, it provides no output. But here, it provides remains at the lost value, either low or high. You got it? So that's it. Very simple. Gap action, differential gap. Okay, good to go. So the gap action controller. Some control loops have two conflicting objectives. Remember, friends, two conflicting objectives. What is that? One is to keep the process variable under control. Okay. And also minimizing the controller output momentum. You got it right? Yeah. One is keep the process variable under control. Others is minimizing the controller output movement. As simple as that. Okay. Such a loop will have a set point. So it is more important to keep the process variable within predefined bounds than to keep exactly to the set point. Okay. Keep the process variable within the predefined bounds than to keep exactly at the set point. Okay. What is the typical application? It's nothing but averaging level control. Something like a surge tank control. You know surge, right? Yes, surge tank level control. But here the process variable is controlled around its set point. Truly, surge control rarely controls around set point because of the surge, right? Yes. So take a typical example, search can control. It's, the process variable is a control around the set point. Okay, right. So controller manufacturer has designed a modification of a standard PID control algorithm for use on processes with such conflicting objectives. What is that? To keep the process variable under control and also for minimizing the control movement. That is why I told this gap controller is a modified version of PID control algorithm. You got it, friends? Yes, this is called the gap control. I hope now it's very clear, right? Okay. It works on the principle of two user-defined control region, one for each of the two control objective. One to keep the process variable under control and minimizing the controller output movement. I think it is very clear, right? Yes, good to go. Now we'll explain the gap action controller with a typical example. Just listen, friends. You can see here, this is your set point. Okay. This is your higher gap limit. This is the lower gap limit. So this is the gap. Okay. Right. Now, the first region you can see here is far from the set point, right? Yes. Outside the gap. And it requires a strong control action to turn the process around the, okay, and bring it to the set point, right? Yes. So here the normal controller settings are used outside the gap, a normal controller setting. Okay. Now the second region you can see here, it is close to the set point, inside this gap within which the controller detunes itself based on a configurable gain multiplier M, usually between 0 to 1. Okay. What for? For no action or reduced control action. Because our objective is to bring it to the, set point, I mean, revolve around the set point, and other objective is to, what do you call it? For reduced control action or no action. Okay. So these are the two objectives. Okay. So the due tuning helps, because we have this, the controller itself due tunes, right? So the due tuning helps to minimize the controller output movement. That is the point here. Okay. To add on further on the gap action, in this type of gap controller, there is no control or reduced action is applied if the process variable falls inside the defined range. If it is here inside the defined range, so no process variable, no action is required. Okay, right. If the process variable stays outside the range, the PID control action is applied to drive the process variable back within the range. You got it, friends? Yes. Another point, very, very important, just listen. Okay, again I repeat. See, there is no control action or reduced action is applied if the process variable is within the defined range. Okay, if the process variable stays outside the defined range, PID control action is applied to drive the process variable back within the range. Okay. Another point to note here is the difference between the regular PID and the PID with a gap control is that for the gap option, there is no control action or reduced control action when the deviation between the set point and process variable is within the certain limit. That is the gap, a kind of a dead band. You got it? Okay. In this type of gap, there is no control action or reduced action is applied if the process variable falls inside the defined range. That is one point. Okay. If the process variable stays outside, PID control is applied to bring it back within the range. Okay. Got it. Another point is there is a difference between the regular PID and the PID with the gap control is that for gap option. What for? There is no action or reduced control action when the deviation between the set point and process variable within the certain limit. So the what I'm going to say is the point is there are two values of gain. One is the normal PID, other is the this value. That is the point. So there can be two values of gain in the PID with gap controller. You got it, friends? Okay. Anything you can write to me. Okay. Right. So this is about the gap action controller. Now, few more. One value of gain, okay, generally low, right? PV is within the gap range. And other value of gain is generally high when PV is above or below the gap range. Okay, right. A default value of 5% measurement span shall be configured. It may be changed, of course, during the FAT commissioning. Okay, FAT or commissioning. So the gap action controller provides a standard PID control action. I'm repeating this. When process variable rises above the gap limit or falls below the gap limit. Very simple. When the process variable is between the gap limit, the controller works with sharply reduced gain or provides no output within the gap limit. Okay, right friends? I think now gap action is clear. Now we see the differential gap. So differential gap provides a standard on-off action. When process variable rises above high gap limit or falls below the low gap limit. Okay, this is the high gap. Okay, this is the low gap. Okay, right. So when a process variable is between these gap limit, the controller output remains at the last value. Okay, remains at the last value. So that is the concept here. Okay, right. So two position on-off controller that actuates the process variable reaches the high or low value of its range. That's the differential gap. This is a typical example. To just add on more with respect to this diagram, if you can see here, the controller will turn on when the output prescribed analog value, that is high value, nominally 95% of the level along high set point is exceeded. It turns on when exceed 95% of LAH. Okay. Then the controller will turn off its output only when the prescribed analog low value, nominally 95% of the level along load along transmitter set point is exceeded. Okay. You got it, friends? So the controller output will remain off until the higher threshold is again exceeded. So this is the typical example of gap controller. I hope now both the differential gap and the gap action is clear. Okay, friends? Right. Now, I want to give you something add-on. Okay. So how to tune a gap controller? To use gap control effectively, this is the pointer. We should set the size of the gap around the set point according to the typical variation of the process variable. Okay, that is the pointer. So that the process variable does not frequently and unnecessarily venture outside the gap. So that is the point. That is why we are defining here the gap. Okay, the above gap, below gap. Okay, friends. So that is the pointer. Okay. Tune the controller for fast response outside the gap. What for? To provide a quick recovery from the disturbances, right? If it is outside, you need to bring it back fast. So that's why tune the controller for fast response outside the gap. Use a gain multiplier of zero point 0.5. If you remember the previous slide, we talked about, right, 0.0 to 1, right? Yeah. So use a gain multiplier of 0.5 or less to minimize the controller output movement inside the gap. Okay. So this is for a normal case. In fact, for integrating processes, sequence, right? Integrating process, divide the calculated integral time, the TI, in the PID, right? TI, integral time, by M. Factor of M means 0.5. What for? To make the integral time longer. Okay, that is the pointer. So this requirement is only for integrating process. Why we are doing? To ensure a stable integral term when the controller gain is reduced inside the gap. So that is the requirement. Okay, the point to take note is do not use a gain multiplier of 0 when controlling integrating processes because the deadband will cause the process variable to continuously cycle through the gap. You know deadband, right? So deadband is nothing but it's a brand of input value in the domain of a transfer function in a control system. Of course, you know, right? Yes. So the output is 0, meaning the output is dead, no action occurs. So that's a deadband. So this will cause the process variable to continuously cycle through the gap. So the point to take note is gap control should not be used in control loop of which the objective is to keep the process variable as close to the set point as possible. Okay. If you want to, keep the process variable as close to the set point as possible, use regular PA or PID, which we have discussed in the previous, sessions. Okay, friends. So that is the point. Gap control should not be used in control loop, of which the objective is to keep the process variable as close to the set point. It will be around the set point, like a search application, search level, a search control application, but you cannot, bring it to the set point. So if you want to use it, then you have to go for other option, PA or PID. So that is the point. I hope you got some insights on the gap controller, friends. If you also feel the same, you can show your support by pressing the thumbs up button. Okay. Yeah. If possible, subscribe. Yeah. See you soon in the next session. Thank you, friends. Take care. Bye-bye.